In the sciences, there are often everyday words that we encounter that have very, very specific meanings. And if we forget that we're talking scientifically, sometimes we slip into our everyday use of those words. Be on your guard to avoid that. A really common place that occurs is with the ideas of accuracy and precision. To most people's minds, those two things are about the same. But to a scientist's mind, they're very different. So accuracy is going to define how close the measurement is to the true value. Now, let me do this graphically so we have some sort of an intuitive understanding. Suppose that we go down to a shooting range, we put a couple of targets up. You can see here that this range of shots, terrible. Wide grouping, not hitting the center of the bullseye. That's going to be low accuracy and low precision. Now suppose that we manage to walk those values in, those shots in, and get them to be right there averaging very well. Oops. There we are. Averaging very well to the bullseye. That is going to be something that is highly accurate. However, that grouping is still really wide. None of them are on the bullseye. They average up to the bullseye. That's going to be something that has high accuracy but poor precision. That stands in contrast to the idea of precision. Precision is all about how constantly you get the same result. That doesn't mean that it's the right result, but how consistent the measurement will end up being. Commonly, this gets reported as standard deviation. And that tells you how far away from some average value a bunch of other values are going to spread. And we say that somewhere within this range is the real value, but here's the one that we managed to measure. That's a way that we would communicate precision. Let me go ahead and erase that. Now let's see a graphic version of that. With precision, we don't necessarily improve the accuracy. And if you notice, we stayed on the low end of the accuracy coordinate, while we did move up on precision. Our grouping got much smaller. All of our values are more consistent, but that doesn't mean that they're right. Now, of course, what we're really after is something that is highly accurate and something that is highly precise. Sometimes we will have to make trade-offs in the lab, either because of time, equipment, money, highly random samples. All these things can cause some sort of a deviation from the case where you have high accuracy and high precision. Now, notice, what exactly is high accuracy? What exactly is low accuracy and precision? We would need to have some nice numeric ways of measuring that and to really communicate and convince a reader. In the sciences, the language that we use to communicate that is statistics. But we're not going to make this into a full stats course. If you take a stats course, or you go to higher level science courses, either in chemistry or other fields, you'll almost certainly see the appropriate statistics to use to describe accuracy and precision. For our purposes, we're going to stay a little bit less accurate and precise. Now, suppose you were to go to the lab and take 4 measurements. Notice we're going to get less graphic here and more numeric. And in this case, I'll bet what they were doing is measuring out 25 milliliters of water. And we know the density of water is typically going to be about 1 gram per milliliter. And that's actually where the original definition came from, but there's a lot of things that go into that and that can cause variations. Now see here that we have 4 measurements that came to be about 25 grams. So it seems reasonable that there were 25 milliliters being weighed. I'll also point out we have a broken axis here. We do that sometimes so that we can compact things and not waste a lot of space while still showing exactly the quality of something and not accidentally lying to the reader. We make sure that we communicate that, though, by having these 2 slashes through there and breaking the axis to really communicate immediately that, hey, by the way, there's a big gap sitting below that. We're zoomed in right now. Okay, anyway, we had 2 on the high side, 2 on the low side, but they're grouped pretty tightly in. If better glassware, I'll bet we could group that in even tighter than this. But this is a case that has highly precise and highly accurate values. We were expecting a value of 25.0 grams because of the physics and the chemistry that we know. We knew that the density of water was 25 grams per milliliter, so we are anticipating a true value of 25 grams, and we stayed pretty close to that. Now suppose we got measurements that looked like this. where everything is clustered up there by 27. Notice that the grouping stayed about the same. I'm not going to say that the precision has changed. However, the accuracy has. So if 25 is going to be our true value, this grouping is going to be highly precise, but notice that it's not very accurate. We want to make sure that we're using those terms correctly throughout the course.